Hello everybody and welcome to this video where we will be solving questions about circuits in parallel and circuits in series. So let's cut straight forward to the case and start with this first question. Here it's asking me to find the equivalent resistance for this circuit. So when we say the word equivalent resistance, it means that I want you to replace these two resistances here, this 10 ohm and this 100 ohm, and replace it with one resistor. So what can I do to replace these two resistances with one resistor? Well, first of all, I have to ask myself, is this a circuit in parallel or is it in series? Clearly, it's in parallel because, as we can see, the resistors here are not connected to the same wire. So the total resistance or the equivalent resistance, we can say that 1 over RT is going to be equal to 1 over R1 plus 1 over R2. Okay, now 1 over R1 is equal to 1 over 10 plus 1 over 100, which is the same if we multiply this by 10 and we multiply this by 10, we will get that 10 over 100 plus 1 over 100, which is equal to 11 over 100. Okay, now it's very important. Don't be hasty here because this is not the final answer. This is equal to 1 over RT. So 1 over RT is equal to 11 over 100. So if I want RT, what I have to do is I have to flip both values. So the final answer right here, RT is going to be equal to 100 over 11, which is equal to approximately 9.09. So the answer is 9.09. Question number 2, determine the equivalent resistance between points A and B. Okay, for this question right here, we can see that points A and B are like separate wires. To fully understand this question, let's try doing this. Let's imagine if this was connected to a source of energy right here as a battery or a cell. Now, this way, it's a little bit more understandable. Now we can deal with it as more than one type of circuit in the same question. How is that? Let's start first of all with this 12 ohm resistance right here and this 4 ohms. We can see that both of these batteries are in parallel. So if we want the total resistance here, I can say that 1 over RT is equal to 1 over 12 plus 1 over 4, which gives us an answer equal to 4 over 12. Okay, now let's remember this is not RT, this is 1 over RT. So this means that RT is equal to 12 over 4, which is equal to 3 ohms. Now, the first step is I want to redraw this circuit one more time like this. But instead of drawing a 12 ohm resistance and a 4 ohm resistance, I will just simply draw a 3 ohm resistance. And I have another resistance here equal to 3 ohms. And I have a resistance here equal to 3 ohms. Now, the case is as following. I have a 3 ohm resistance and a 3 ohm resistance and another 3 ohm resistance. Are they in parallel or in series? Well, actually, for this resistance here and this resistance here, they are in series, right? So I will draw it one more time, and I know that the total resistance for a series circuit is going to be R1 plus R2, which is equal to 3 plus 3, which is equal to 6 ohms. So I will replace these two with a one resistor equal to 6 ohms, and I will draw on my circuit one more time. This is equal to 6 ohms, and this is equal to 3 ohms. Now, this resistor right here and this resistor right here, they are in parallel. So I want to find the total resistance one more time. 1 over RT is going to be equal to 1 over 3 plus 1 over 6, which is equal to 3 over 6. This is 1 over RT, so RT is going to be equal to 6 over 3. So the answer, the final answer is going to be 2 ohms. As we mentioned in the previous video, when we solve these types of questions, maybe we will be dealing with more than one type of circuit within the same question. So what happened here is I had more than one type of circuit. I had parallel circuits and I had series circuits at the same time. So I started dealing with them as parts. I first dealt with the 4 ohms and the 12 ohms here as they were in parallel. Then I dealt with this resistor here and this resistance here, which they were in series. Then finally I got this final simple shape with 2 resistors connected in parallel. Now, if we look at the choices, we can see clearly that the answer here is equal to 2 ohms. Next question. 4 resistors equal to R are connected as shown. What is the total resistance? Okay. Just like the previous question, let's imagine if it was connected to a battery or something right here. Now, I have a parallel circuit right here, and I have another parallel circuit right here. So for this parallel circuit, 1 over RT is going to be equal to 1 over R plus 1 over R, which is equal to 2 over R. But this means that RT is equal to R over 2. Now, I can replace this resistance and this resistance with one resistance equal to R over 2, and I will have the same value here because these two are also in parallel. So if I want to draw the circuit one more time, I will have R over 2 right here and another R over 2 right here, and I will finally get an answer equal to R over 2 plus R over 2 because these two are connected in series. So the total resistance is going to be R over 2 plus R over 2. The answer will be R. So the total resistance is R, so the answer is clearly C. Now, which of these resistors has an equivalent resistance of 1 ohm? Well, we can do this really quickly. This is equal to 1 over 2 plus 1 over 2, which is equal to 2 over 2, which is equal to 1. So 1 over RT is equal to 1, so RT is equal to 1. So I can say this is equal to 1 ohm. I can replace it with 1 ohm and 2 ohms. So it's clearly not the right answer because 2 and 1, this is in series, 2 plus 1. The total resistance is 3 ohms for this one right here. So it's not the correct answer. Okay, for this one, I will add this resistance and this resistance because these two are in series. So I can say that I will have a circuit looking like this. This is going to be 4 ohms right here, and this is going to be 4 ohms. And they are in parallel, so 1 over 4 plus 1 over 4 is equal to 2 over 4. Therefore, RT in this case is going to be equal to 4 over 2, which is equal to 2 ohms, so it's not the right answer. And for this one right here, 1 over RT is going to be equal to 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2, which is clearly not going to give us a 1 ohm resistance. And finally, if I look here, 1 over RT is going to be equal to 1 over 2 plus 1 over 2. This means that 1 over RT is going to be equal to 1, which means that RT here is equal to 1 ohms. So the answer is clearly D. Next problem. Questions 5 to 8 are related. For the circuits shown, assuming a 30-volt battery with no internal resistance, what is the voltage across the 3 ohm resistor? So it's asking about the voltage or the potential difference across the 3 ohm resistor. So I will ask myself, is this a parallel or a series circuit? So it's clearly a parallel circuit. So for parallel circuits, we know that the potential difference is going to be the same for all the resistance. So this is going to be 30 volts, this is going to be here 30 volts, and this is going to be here 30 volts. So the answer is directly 30 volts because the potential difference doesn't change in parallel circuits. What is the current in the battery? It's asking about the current in the battery, or the current right here before it starts separating. So what we have to do here is I will need to find the equivalent resistance for these 3 resistors, and I can do the following. I can say that 1 over 6 plus 1 over 3 plus 1 over 3. If I multiply this by 2, and I'll multiply this by 2, and multiply this by 2, and multiply this by 2, I will get the answer equal to 1 over 6 plus 2 over 6 plus 2 over 6, which is equal to 5 over 6. But this is not RT. RT is going to be equal to 6 over 5. Now, we want to find the current. We know from Ohm's law that R is equal to delta V over I. So I can clearly say that I is equal to delta V over R. Now, I have the potential difference. The potential difference is equal to 30. And the resistance here is equal to 6 over 5. We can use the keep flip change, which means that this is equal to 30 multiplied by 5 divided by 6. We will get the answer equal to 25 amperes. So the answer here is equal to D. Next question. The correct way to connect a voltmeter to read the potential difference in the 6 ohm resistor is, which of these choices? It's asking for the potential difference at the 6 ohm resistor. So it's clear that the answer here is C. Next question. The correct way to connect the ammeter to read the current for the whole circuit. So we want the current for the whole circuit. Is the answer A, B, C, or D? Well, let's start with D. D is incorrect because the ammeter here is connected in parallel, and we know that ammeters are connected in series. So we can exclude D, we can exclude C, and we can also exclude B because they are all connected in parallel. So the only true answer is A. What will the reading of the ammeter in the image below be? Okay, now it's asking me for the current right here. Since this is a parallel circuit, we know that the potential difference is going to be the same for the 3 resistors. So the potential difference here is 30, here is 30, and here it is also 30. We want the current. We know that the current is equal to the potential difference divided by the resistance. And this is really straightforward. The potential difference is equal to 30 because it's the same across the whole circuit, divided by the resistance, which is 30 over 6. So the answer is 5 amperes. The relationship between the current in resistor 1 and 2 in the image is, this is a series circuit, and we know that in a series circuit, the current will remain the same throughout the circuit. So we can say that they are equal. The current in the 2 ohm resistor and in the 4 ohm resistor is going to be the same. So the answer is they are equal. Next and final question. The reading in V1 compared to V2 in the image is, now, let's look here quickly. It's asking about the reading of the potential difference. So this is a series circuit, and we know that the potential difference is not the same in a series circuit. Now, if we want to do a very quick calculation, we know that the potential difference, delta V, is equal to R multiplied by I. Now, the current is going to be the same. So let's just keep it I, and let's call it I. For the first reading of the voltmeter, V1, let's call it, it's going to be R multiplied by I. R is equal to 2 multiplied by I, which is the current. V2 is going to be equal to R multiplied by I, which is equal to 4 ohms, multiplied by the current. So it's clear that the potential difference V2 is double V1, or we can say that V1 is half of V2. Now we solved a bunch of problems about circuits in parallel and series. These questions need practice. You can watch the video again and again until you get the hang of all the ideas we solved in this video. We hope to see you in the next videos, so stay tuned.